The calculation of a heat exchanger design involves several steps to determine the required heat transfer area, heat transfer rate, and other key parameters. Here are some of the key calculations involved in heat exchanger design. 1. Calculation of heat duty. The first step is to calculate the heat duty, or the amount of heat that needs to be transferred between the fluids. 1. This can be calculated using the following formula. Q equals mxcpx increment T, where Q is the heat duty in kW or BTU per hour, m is the mass flow rate of the fluid in kilogram per hour or pound per hour, Cp is the specific heat capacity of the fluid in kilojoule per kilogram K or BTU per pound degree F, and increment T is the temperature difference between the inlet and outlet fluids in degree C or degree F. 1. Calculation of overall heat transfer coefficient. The overall heat transfer coefficient, U, is a measure of the overall heat transfer rate between the fluids in the heat exchanger. 1. This can be calculated using the following formula. 1. U equals 1, high plus increment x, K plus 1, HO, where high is the heat transfer coefficient on the hot side, HO is the heat transfer coefficient on the cold side, increment x is the thickness of the heat transfer surface, and K is the thermal conductivity of the heat transfer surface. 1. Calculation of heat transfer area. Once the heat duty and overall heat transfer coefficient are known, the required heat transfer area, A, can be calculated using the following formula. A equals Q, Ux increment Tm, where increment Tm is the logarithmic mean temperature difference, LMTD, between the fluids in the heat exchanger, which can be calculated using a formula that depends on the specific heat exchanger geometry and flow configuration. Sizing and geometry calculations. Once the heat transfer area is known, the sizing and geometry of the heat exchanger can be determined based on the specific heat exchanger type and application. This may involve calculations of tube diameter, tube length, shell diameter, plate spacing, or other geometric parameters. Pressure drop calculations. Finally, pressure drop calculations may be required to ensure that the fluid flow rates and pressures are within acceptable limits for the specific application. This may involve calculations of pressure drop across the heat exchanger, or calculations of pump or fan requirements to maintain adequate flow rates. Overall, heat exchanger design calculations can be complex and iterative, and may require adjustments and modifications as new information is gathered during the design and testing phases. It is important to work with an experienced engineer or team of engineers to ensure that the heat exchanger design meets the specific requirements and constraints of the application.